Rise and shine, everyone. This problem appears in AAHL test. It says in the triangle ABC is 90, AC is square root of 2, and AB equals BC plus 1. It is also given that cosine A minus sine A equals 1 over square root of 2. If we're going to draw the figure, a right triangle ABC, our B is our 90 degrees. This is angle A, angle C. So this AC square root of 2 and AB is equal to BC plus 1. So to solve problem number 1, it says by squaring both sides of the equation above, solve the equation to find the angles in a triangle. This is the given equation. So let's do letter A. Cosine A minus sine A equals 1 over square root of 2, and squaring both sides gives us cosine squared A minus 2 sine A cosine A plus sine squared A is equal to 1 half. This is an identity which is equal to 1 minus 2 sine 2 sine A cosine A equals 1 half. And this could be written as 1 minus 1 half is 1 half equals 2 sine A cosine A. And this is another identity which is equal to 2 sine A. So we're saying that 2 sine A equals 1 half. We look for, we say that sine 2A, let me erase this. The identity this is a double angle identity. Sine 2A equals 1 half. So we look for the measurement of the angle. So 2A is arc sine of 1 half, which is 30 degrees. Therefore, our A here is 15 degrees. But looking at the problem, we are asked to find the angles in a triangle. So let me draw that again. So this is our B, this is our A, and this is our C. We know this to be 90. So if this is 15 degrees, our C is the complement of the angle A, so that's equal to 75 degrees. So these are the two angles that we're looking for in letter A. For letter B, we are asked to find the measurement of BC, and then we show later on that sine A is equal to this given amount by applying Pythagorean theorem. So let's have this again. Let me add another page. So for number 2, let me draw that once more. So we have here A, B, C, for the square root of 2, and this is BC plus 1. Applying Pythagorean theorem, the sum of the squares of the legs is equal to the square of the hypotenuse. So we have BC squared plus AB squared, which is represented by BC plus 1, is equal to the square root of 2, so that gives us 2. Simplifying this, we have BC squared plus BC squared plus 2BC plus 1 equals 2. Now we can combine similar terms, so we have 2BC squared plus 2BC plus 1. We can combine already the constant, so minus 2 plus 1 gives us minus 1 equals 0. So this is in general form. So we can find the measurement of BC. And this BC, let's say this is x. So this is in the form of 2x squared plus 2x minus 1 equals 0 in quadratic form. Now we're looking for x, so we can solve for x or BC by applying quadratic formula. So in quadratic formula, we have BC equals the negative of B. By the way, this coefficient is the A and B, and this is C. So the negative of B plus or minus square root of B squared, which is 4 minus 4 times A times the value of C all over 2 times A. So this gives us negative 2 plus or minus square root of 12 over 4. So we can also analyze, solve for or simplify this. This is same as negative 2 plus 12 is 4 times 3. We can take out the square root of 4, which is 2 square root of 3 all over 4. And then again, we can take out the common factor, which is, let's say, 2. So that shall be equal to negative 1 plus minus 2, or square root of 3 now, over 4. So simplifying this gives us square root negative 1 plus square root of 3 minus all over 2, or we can use negative square root of 3 minus 1 over 2. So this is now the value of our BC. Okay, so for letter C, we are not yet done with this. We are asked to find sine A. So let us do it here. We can use SOHCAHTOA for sine A, where sine A equals the opposite, which is BC, over uh, hypotenuse square root of 2. And our BC is square root of 3 minus 1 over 2 all over square root of 2. So this gives us square root of 3 minus 1 over 2 multiplied by the reciprocal of that, which is 1 over square root of 2. And now rationalizing both sides by multiplying by square root of 2 square root of 2 over square root of 2, we shall have square root of 2 square root of 3 minus 1 over 2 times square root of 2 times square root of 2 is just 2. So simplifying this, we have square root of 6 minus square root of 2. Well, it's plus or minus, but we are just proving that sine A is equal to my square root of 6 minus square root of 2 all over 4. So this is our sine A. Okay, so we're done with letter. Okay, this is letter B. Now for letter C, let's go back to page 1. Hence or otherwise, calculate the length of the perpendicular from B to AC. Calculate the length of the perpendicular. Okay, let me add another page. Let me draw the figure again. So we're looking for this one, this figure, which is H. And then again, A, B, C. We can actually use sine rule to find the value of H. So we know this to be right here, because it's perpendicular. So we can use SOHCAHTOA. So where we can use for sine A, because we know the value of sine A. Sine A is H over the hypotenuse. In this problem, where this is right, okay, this is the hypotenuse over AB, no? Over AB. Okay, so our H is equal to AB sine A. And AB is given to be BC plus 1. And our sine A while ago, and even if you were not able to solve B, it is stated that sine A is equal to square root of 6 minus square root of 2 over 4. So you can miss the answer in letter B, but here you can just use the value for A. So BC plus 1, what is BC again? Let us move back. BC is square root of 3 minus 1 over 2. Okay, so this is equal to square root of 3 minus 1 over 2 plus 1, let's say 2 over 2, and we multiply this by square root of 6 minus square root of 2 over 4. Okay, simplifying this one gives us square root of 3 plus 1 over 2 multiplied by square root of 6 minus square root of 2 over 4. Okay, so we can now multiply the two numbers. So we shall continue here. Square root of 3 times square root is square root of 18. Square root of 18 minus square root of 6 of usual method. And then the outer square root of 6. And then the last terms minus square root of 2 over 8. Now we have, these are additive inverses, the two. So we have square root of 18 minus square root of 2 over 8. 8 is, let's say, 18 is 9 times 2. So that's the same as 3 square root of 2 minus square root of 2 over 8. And 3 minus square root of 2 minus square root of 2 gives us 2 square root of 2 over 8. So if we simplify this, we shall have square root of 2 over 4. So this is the length of the perpendicular H. Square root of 2 over 4. So that concludes the answer to this problem number 11 in AAH question. So you can subscribe so you'll get updated. Okay, goodbye everybody. I'll see you again.